So, hi and welcome to Dask on Google Cloud, or Scale Model Training in Minutes with Dask plus Rapids on GCP AI Platform. We have Remy Welch. She's a customer engineer for Google Cloud who specializes in machine learning and data analytics. She's worked with multiple customers to use Dask and Rapids with NVIDIA GPUs for machine learning use cases.
Thank you very much. Hi, everybody. This, I guess, is now the last talk of the Dask Summit. So thank you all for sticking by and joining. And hopefully this will be a great ending to what has hopefully been a great conference for y'all as well. I've got a lot to talk about, so I'll just go ahead and jump right into it because I would like to get to a demo of the Vertex/AI platform at the end. Okay, so first, why use Dask on the cloud? First and foremost, you have machines, virtual machines of all shapes and sizes at your disposal. So what that means is that you have pretty much as much memory, as many cores as you want, as much compute power as you want at your disposal, with just a few clicks of a button or a couple lines of code. It's also very easy to get started, particularly on Google Cloud, which is who I work for. But we have virtual machine instances and images that come pre-installed with both Dask and Rapids and a variety of other libraries, like NumPy and Pandas, everything else you need pre-installed, so you don't have to worry about that configuration, which can often take more time than we want it to. If you're using Vertex or AI platform training, which is where you would submit your code as a job, it can then be executed on a Dask cluster, which is spun up. Your code is executed and then spun down, and you're only paying for the actual training that you're doing, which is nice and very cheap. Fourth, when it comes to data, you can read these massive data sets very quickly from either Google Cloud Storage, which is GCS, or BigQuery. And rather than having everybody having different copies of the data and mounting them in different volumes on your virtual machines, which you can do, but having it in a single place in a data warehouse in cloud storage means that you don't have that sometimes crazy proliferation of data and always worrying about who has what copy of the data. It's all easily managed on the Google Cloud platform. And along the same line, when you're using AI platform, all of your code, your teammates' code, their experiments, all the models they run, all the logs from the runs that you've done are in one place. So you can go back and look at yours and see what you did. And you can look at your colleagues and say, oh, he ran this model and it got this amount of accuracy. And that, of course, is great for collaboration. So, I talked about these virtual machines that are available just to kind of show off a little bit on what you could have available to you on Google Cloud. As you can see, we have a variety of different GPUs, including the A100s. We're the only cloud that has the 16 node A100 or 16 A100 GPU shape. And each of those A100s has 40 gigabytes of memory. So that means with the 16, you have 640 gigabytes of GPU memory available to you. We also, of course, have the TPUs, where you can get up to 4 tebibytes of memory. And there's a bunch of different shapes there, the TPU pods and the super clusters. And then we also just have, of course, our CPU shapes with varying different, ratios of CPUs to memory, all the way up to our mega mem instances, where you can get almost 12 terabytes of system memory on a single machine. So there's a lot to play around with, and all of this, is at your disposal. You just have to sign up. In terms of using Dask, We also have a variety of different ways that you can use it. Each of, we've tested these aren't theoretical. We've tested these all out ourselves. On the left-hand side, you can totally completely manage and spin up your own cluster, using either the UI or the API for compute engine, and using Docker containers or Conda to install what you need there. Same for our Kubernetes engine or GKE. That's the same thing. You have your own cluster, but for GKE, some of that Kubernetes networking is abstracted away for you, so you don't have to deal with as much of the networking headache for your cluster. But again, that's Dask Kubernetes. You're completely in control of your cluster there. Dataproc, one of my colleagues, Brad Miro, did a presentation on using Dask on Dataproc earlier this week. So I encourage you to check that out. That's also a managed cluster. And then finally, all the way on the right, we have Vertex AI or AI Platform. Earlier this week at Google I/O, we announced Vertex AI, which is, if you're familiar at all with our AI platform, it kind of is the AI platform, just with a few more features. So for the purposes of this presentation, when I say Vertex AI, it's the same thing as AI platform. When I say AI platform, it's the same thing as Vertex AI. I'm just going to use those interchangeably. But in that case, we have our Dask Docker images that are very easy to deploy. Again, you don't need to manage any kind of installation or configuration of the Dask cluster there if you don't want to. And all of that is on top of our cloud storage, which is where you would be keeping your data. And then you're using the GCS FS library to read the data into your instance, into your Dask array, Dask matrix, what have you. I'll talk a little more about using Dask on GKE. So there is currently on GitHub, we have this tutorial, the code, and there will soon be a blog, accompanying blog post coming with it. So there's the code to spin up a Kubernetes cluster with a scheduler pod and a worker pod, then execute some Dask code on that cluster, and the cluster will add and remove workers based on a performance suite. So this is multi-worker Dask. You can currently do multi-worker or multi-GPU. You cannot do multi-node Dask yet, because in taking away and managing some of the security and the networking features of the Kubernetes cluster, each machine only has a single port exposed currently, and Dask needs multiple ports exposed. So our teams are currently working on making that possible so that you can do multi-node Dask, but still multi-worker and multi-GPU is still plenty powerful. Also coming soon, we'll have just some additional code so that when you spin up this Kubernetes cluster, it also has Jupyter Lab already in it. So instead of submitting your code from your local machine to the Kubernetes cluster in the cloud, you can just do all of your work in the cloud, which helps with some of the authentication initial setup. And then we also have, just as an extra note now, multi-instance GPUs for use in GKE. So you can run multiple copies of the same model on a single GPU. Just an extra little fun note there. All right, so I'm going to jump in soon to the AI platform and show you a little demo of how you'd use Dask on AI platform or Vertex AI. First, I'm just going to give you kind of an overview of what Vertex AI or AI platform is. So a typical data scientist, the workflow would be you have your data sitting in either BigQuery or Google Cloud Storage. You then want to start doing your development. So you would spin up a Vertex notebook, which is essentially Jupyter Lab and whatever kind of model framework you're using pre-installed on a machine. And again, you can choose, what kind of machine you want it to be. We have, scikit-learn, images, TensorFlow, PyTorch, and also Rapids and Dask. So it's just a few clicks of a button to spin that up. You do your development in there. And now you say, okay, I have this model that looks pretty good. I want to do it on the full, massive, train it on the full data set and play around with some, like adding additional power to make the training go quicker. You can then package your code and submit that to Vertex training, which will spin up a Dask cluster for you, do the processing and training based on the configurations that you set, and then spin that cluster down when it's completed. And you have in AI Platform, you have evaluation metrics and CPU utilization and such, all your logs in a single place for you to be able to evaluate that model. Assuming you find the kind of configuration that you want, you can then deploy that model to Vertex prediction for either batch predictions, or you can put it up on an endpoint for online inference. And all of that is accomplished in the same platform. I strongly encourage you to look more at Vertex AI. I don't really have the time to fully go into it here, but if any of this sounds interesting, which hopefully it should, I do strongly encourage you to look at that. Oh, I totally forgot about Vertex pipelines as well. So on top of all of this, we also have a managed MLOps pipeline service, which is basically a managed TensorFlow extended / Kubeflow pipelines interface for you to be able to build, MLOps pipelines. Okay, now I will jump into a little demo here. Okay, so here is AI Platform. Vertex AI, it will look very similar to this. But you can see here I have all my different notebook instances. So I have a new project I want to start. I can spin up this new instance. You can see here all the different frameworks that I can choose from. We want the Rapids version 0.18, which also includes Dask. So I'll go to advanced options here. You can give it a name, choose what zone you want it deployed in. There's different GPUs available based on what zone you choose. You can choose what machine type. So earlier, I showed you all those different types of machines. Here, you can choose from all these different types, up to 96 CPUs if you wanted. 360 gigabytes of RAM. We'll just stick with the 4 CPUs. You can also attach GPUs to it as well. So we, could say one T4, automatically install the GPU driver here. And pretty much all of these configurations are changeable too. So, right now we're attaching a 100 gigabyte boot disk. Say I decide I want to, you do a larger data set. Maybe my data set is 100 something gigabytes. I can very easily change this to a 200 gigabyte boot disk. And you can see over here, it'll tell you approximately what that will cost. So it's less than 50 cents hourly. And if you left it running for an entire month, you'd be, it's $284. So I'm not going to create this. It takes a couple of minutes. I have one already spun up, but you can see here back on my notebook page, I have all of these kind of grayed out ones. So these are instances that I've stopped. So you can stop an instance if you're not using it. And in that case, you don't pay for, you're not paying for it when it's not running. And then if I wanted to start up this project again, I could just click start here, and all my work is still saved, just like I never left. So we'll go into this notebook, which has the same configurations as I just showed you here. So you can see, I'm sure all of you are familiar with Jupyter Lab. This is kind of the main portal into your instance. You can also SSH into it. It is a virtual machine, so it's not like you're restricted to having to use, a terminal in Jupyter Lab. But there's also, GitHub. You can manage your GitHub through it. But you can see here, so here's my notebook. I'll just run these, importing. Again, I didn't have to install anything to get started, but you can, pip install other packages if you want. But in this case, I didn't need to. I'm doing a local CUDA cluster, so that includes the GPU that I have attached additionally to the masternode machine. Here, I'm reading the data in from a GCS bucket. And this data is the Higgs boson data set, which is, it's 10 gigabytes. So it's 10 1 gigabyte files that I'm reading in. You can see here, I'm just spitting out the number of partitions. And again, we're using the GCS FS library to read this in from GCS. It's a bit more performant than GCS Fuse, if you're familiar with those libraries. And then here I'm doing a totally unnecessary, like has no real function, group by the key in the data set, just to show you, it's now in this Dask D matrix. And this is executing right now. It usually takes around like a minute and 20 seconds to finish. It's, a pretty, it's a 10 gigabyte data set, and with this group by, it needs much more than 10 gigabytes of memory to complete. So you can see here it took about a minute and a half. That's really just to show you, you can use Dask on a notebook. But so say now I've finished, I've created I've finished doing my development. I have like an XJBoost model that I want to, to do training on, and I want to do it on the full training data set, which in this example is 100 gigabytes, so quite large. What I'm going to use is Vertex or AI Platform training. So you can see we would have our XJBoost training code is here. You can see we're doing a Dask PDF data set based on our data, which will specify the location in GCS later. We're creating our Dask device quantile D matrix, which is the optimized for XGBoost code. It's pretty boilerplate stuff. And now here we're defining our local CUDA cluster with the parameters of the number of workers, and you can also specify number of threads per worker. AI Platform training is on top of GKE, so we have the same restriction currently where we can't do, we can just do multi-worker and multi-GPU training, not multi-node. But again, the team is working on this, and you can still get plenty of power out of multi-GPU here. So there's our XJBoost code. We package that up. We're going to create a image from a Docker file. So we're using this base Rapids image, which has Dask. We're just adding GCSFS. We're adding our XJBoost code, which I just showed you. So that's the image we're running. And then here is where we're going to specify our Dask cluster. So you can see here, this is the training data set that we're using. This is like all, this is currently 100 gigabytes of data here. We are doing 4 A100, so we're attaching 4 GPUs. Here you're specifying, it's 4 NVIDIA Tesla A100s. We're pointing to the image that we created with that Docker file, and then specifying the A2 compute optimized machine here for doing as our master node. So to run this, it's just as simple as executing this code here. So we'll go to our terminal. So it's just, you're doing an AI platform job submit and pointing to that configuration in the YAML file. And then click go, which I'm not going to do because, as you may have heard, there is a global GPU shortage. And so we've been asked not to use GPUs for demos, but say I clicked enter, it would click off a job, and here I'll show you a job that I've run in the past. So here you can see all the jobs that you've run. Here is one you can see that I ran with V100s. So we did 8 V100s, and this is on the full 100 gigabyte data set. So you can see it took 19 minutes to execute. If I wanted to look at the logs, I could click here. The logs are kept by default 60 days, and this was executed over 60 days ago. So we're not able to see that, but if it was right after I ran it, I could see, CPU and memory utilization. Currently with the custom containers and some of the GPU types, so like the A100 GPUs, we're not seeing GPU utilization currently. That is a bug, but for a more typical Vertex training job where you're using one of our so-called supported containers, which is TensorFlow, PyTorch, all these pre-configured containers, you get the full metrics for those. But for Dask, because it is more open source, we are using a custom container and specifying all of these things custom. It doesn't always work as smoothly as it does if you were to do like TensorFlow or PyTorch, but it still works perfectly well. Still definitely gets the job done. So again, like if I wanted to, just to show you, how easy this is, if I wanted to change this to 2 V100s, literally as simple as, just changing the machine type, save this file, and then I would execute this command again and kick off the other job. It's really that easy. Okay, jumping back here. So we tested out, a variety of different configurations here just to show you the outcome. So we, with just a CPU, so here this is a 64 core machine with, I believe that's 256 gigabytes of memory. Just using normal XGBoost, NumPy pandas, you really can't even do it with a 100 gigabyte data set. So on just 30 gigabytes, the total time was 19 minutes on that really souped up machine, which is not bad. But then when you're using GPUs on the full 100 gigabytes, you can see the time has even gone down, or it's, even though it's more than double the data, the time has only gone up by a few minutes. So you can see the GPUs are incredibly performant. in these cases. So this is the total time the job took to execute. Around 11 minutes of that currently is in the actual provisioning of the resources. So you kick the job up and it has to spin up the cluster. It takes around 11 minutes when you're using GPUs. It's around 7 minutes when you're using just CPUs. The team does recognize that, you know, when you're talking about a 20-minute job, 11 minutes of startup time is, you know, fairly significant. They're working on getting that provisioning time down. But, you know, when you're talking about jobs that can take hours to execute, you know, 11 minutes is fairly negligible. And then, you know, just talking in terms of like the cost of this, you're paying for the time that the cluster is spun up. So like for the 4 T4s, this job was just over $1 to complete. For the 4 A100s, that one was, I think just under, yeah, it was just under $5. So for the amount of like massive compute power that you're getting here, you're really not paying very much for it at all. So yeah, this is just, you know, to show you what some of my other colleagues have done with Dask on GCP. Did some analysis on the Fannie Mae data set, which is 1.8 billion records just on the AI platform notebook. So for a data set that size, you would never be able to do anything with it if you're just using your computer and, you know, your traditional PyData stack, you just wouldn't be able to do anything. But by spinning up an AI platform notebook with GPUs and using Dask, you know, it's very easy to get started, you know, to do some analysis and train a, excuse me, and train a model on this data. Also have submitted to some Kaggle competition here. So this is using Rapids and Dask and Light GBM. Some outcomes, you know, is 100 million rows read into a data frame in less than a minute. You know, took a couple minutes to process and train. You know, quite powerful there. And with that, that is everything I have. Let me see. Doesn't look like there are any questions. Please feel free to add any, and definitely reach out to me if you want to learn more about any of the tools that I described today. I have here in the deck, you know, there's a number of different tutorials and you know, blogs about how to get started using GCP. You know, if you want to try out GKE, we have that code that, you know, if you want a cluster that's like your Dask cluster to be sticky, go with GKE. If you want to get started quickly, go with Dask on AI platform. If you're somewhere in between that, you know, you could try out Dataproc. But yeah, thank you all for joining, and thank you all for coming to the Dask conference. I hope it was great.
Thank you. Thank you for the talk.